All right, now we're going to look at some examples of how to do indifferent integration, or the antiderivative. So what we have here is the integral of x plus 1 all over the square root of x dx. And the first thing you need to understand is that there's no such thing as a integration quotient rule or anything. So what I'm going to have to do is I'm going to have to send that to the top. So actually first what I should do is say that this is x to the 1/2 power, and then I'll just rewrite it. So we have then the integral of x plus 1 all over x to the 1/2 power dx. And now I'm going to separate out the fraction, so that should be the integral of, so now it's the integral of x over x to the 1/2 plus 1 over x to the 1/2. Oops, that's a really small 1/2. Something like that, dx. Okay, now just do the division to simplify. So we have the integral of x to the 1/2, and I'll make this into, I'll bring that one up to the top, so that should be plus x to the negative 1/2 dx. Okay, like that. I should probably write it like that now. Okay, now using the power rule from yesterday, add 1 to the power, all over, and then it'll be, let's see, 1/2, oops, where's my pen? 1/2 plus 1 over negative 1/2 plus 1. So now my new powers should be, and this would be the integration, so this would be x to the 3/2 all over 3/2 plus x to the 1/2 all over 1/2 plus some constant c. Okay, now these fractions on the bottom, I don't like those, so I need to bring them to the top, I have to find the reciprocals. So the first one should be 2/3 x to the 3/2 power plus 2 x to the 1/2, still plus c. Now I will accept this here as the answer, but just so you know, you can do a little bit of factoring if you wanted to. You could say, well, let's actually factor out all the numbers here. And so I'm going to go ahead and factor out a 2/3. And then what's going to happen is this becomes x to the, just x to the 3/2, and then plus, and this actually will become a 3. If you redistribute it, it should come back out to the 1/2, and then plus c. I don't need to count this, I don't need to factor anything out of the c. The c will never change because it's just some arbitrary number. We just leave it as c. And then also, if you look, I think this might be example 4 in the book. If you wanted to, it also shows how to factor out an x to the 1/2. So this would be 2/3 x to the 1/2, and then times x plus 3 plus c. Okay, so let's look at another example here. Hold on. All right, let's look at another example here. Let's do the integral. Let's do the integral of 2 over the square root of x dx. Okay, just like before, I'll need to rewrite that one as x to the 1/2 power. And so we'll also have to send it up to the top. So this should just be equal to the integral of 2 x to the negative 1/2 power dx. Okay, add 1 to the exponent, and then divide by it. So then we should end up with 2x to the 1/2 power all over 1/2. Rewrite this, send it up to the top, so you should end up with 4x to the 1/2 plus c. Okay, let's do another one here. Let's go with one like this. T squared plus 1 to the second dt. Okay, now this one here we're actually going to have to do, well, we can't do a product rule because that doesn't exist. We're actually going to have to FOIL this out. T squared plus 1 times t squared plus 1. Okay, now so FOILing this out, we should end up with t to the 4th plus 2t squared plus 1, and we have to integrate this whole thing. Now the nice thing is, when there's this many terms, you can always just integrate each one separately. T to the 4th dt plus the integral of 2t squared dt plus the integral of 1 dt. And then do each one separate, so this would be t to the 5th over 5 plus, 2t to the 3rd over 3 plus t, and then plus c. Okay, and I'm sure we could figure out some way to combine this, but this here is answer enough. Okay, and the last example I'll go through is we'll do the integral of the cube root of x times x minus 4 dx. First thing I'm going to do is I'm going to rewrite that one there. I'm going to rewrite it as x to the 1/3 power. Now again, I don't have a product rule, so I am going to have to distribute this through. So we'll end up with x to the 4/3 minus 4x to the 1/3. Oh, excuse me, integral and dx there. Well, same thing. Add 1 to the power to everything, so we should end up with x to the 7/3 over 7/3 minus 4x to the 1/3 over 4/3. Excuse me, 4/3 up there, 4/3 power. Plus c. Rewrite the fractions here. Send them up to the or flip them over, reciprocal. So this would be, excuse me, let me rewrite that, 3/7 x to the 7/3 minus, well, 3/4. That changes to a 3/4. 3/4 of 4 is just 3 x to the 4/3 plus c.